I hope you are doing extremely good. So today we are going to solve LeetCode daily challenge problem. So this problem states that here you are given an array of integer nums and an integer target, and we need to return the number of non-empty subsequence such that in the subsequence the minimum element and the maximum element, the sum should be less than the target, and subsequence will be too large, the sum will be too large, so we need to model you with 10 power 9 plus 7. So let's understand this problem with a small example. So consider this test case which is given in the problem 3368. Now 3, for this 3 there is minimum value is 3 and maximum value is 3, so the sum would be 6, and so this 3 is the same for 3 is also same for 3 and 6. The minimum is 3, maximum is 6, so sum is 9. 3 6, this is 9, 3 3 6, it is 9. Suppose you take 6 comma 8, what would be the sum? 14, so it is greater than 10, so we will exclude it. So in this way, if we think the first approach to in our mind, we can say that uh, we can generate all the subsequence like include, no, you know, right? Now we have some elements a b c d. You need exclude, include or exclude, include or exclude, include or exclude, include or exclude. So if we generate in that way, we will get total 2 power of n, and after generating each subsequence we need to iterate it, and we need to calculate minimum value as well as the maximum value, so it will take order of n. So total the time complexity would be 2 power n into n. uh, so let's see the constraints and decide like whether it will work or not. So if you see the constraints, the length is 10 power 5. So if you see that 2 power 10 power 5, it's like too large, so we can't go there. And if n is 20, then 2 power 20 into 20, we can do this. If n is 25, still we can manage it, but it's not compatible with our compiler, so this solution will not work. So let's think of an dp. If we think of an dp, now include exclude, and I will be there. We just changing continuously, and there will be maximum value which will be changed and minimum value which will be changed. So there will be three attributes, and I is 10 power 5. So if you make a DP table, and the maximum value and minimum value can be 10 power 6 and 10 power 6. So if you make a DP table, you should make 10 power 5 into 10 power 6 into 10 power 6. So you can solve it. So with this DP is not feasible. DP is feasible until 10 power 6, or hardly it will go to 10 power 7. So DP solution is also failed. Subsequence generation is failed. DP is failed. So let's see like whether greedy will work or not. So coming to greedy, we can think like this. Uh, the first thing is that subsequence. In subsequence, the order matters, order not matters. In which case the order will be matter. Suppose you have a string a b c d e. In this there is a subsequence a d e. If you reverse it, it will become e d e. If you want to find out all the substrings which contain a d e, then this order matters. If you change this order, it will fail. But if we have something like this, like there is a condition like what is the how many vowels are there, or which is the minimum character and which is the maximum character, then the order doesn't matter. So in this, if you see the integers, if you see that this test case, where this test case has gone, 3368, 3368. If you see this is in this, the order doesn't matter because all the subsequences are valid and we only need the maximum and the minimum. So let's see like how we need to go further. So suppose we have 3 3 6 8, and one thing we will get our mind is that we need to fix one point, and we need to check like with this 3 as a minimum element, how many subsequences are possible. So let's think in that way. Let's see like for bigger test case. Let's consider this 233 468 233 467. So suppose we are at 2, and what is the target? Target is 12, right? We are at 2, and let's take target as 8 to get better understanding. Target is 8. Target is 8. Now 2 plus some x equals to target. Target is 8. X is equals to 6. So till 6 it's valid. So all the subsequence which the minimum value as 2 will be 3, 3, 4, 6 will be included, and 7 will be excluded. So let's see, like 2 is included for all this, and we have 4 cases: x1, x2, x3 and x4. The, what we can do is, this is 3, this is 3, this is 4, this is 6. What we can do, include, exclude, 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 include, exclude, exclude, include, exclude. In this way we can do all the possibilities. So total how many we will generate? 2 power n. So how many numbers are there, like from this 6 to 2, how many integers are present in between? We can see that all the that many subsequence we can generate. So this is the first observation we can do. And second is that is not mentioned, like the array needs to be sorted or array need not to be sorted. We have to sort it, because if we don't sort it, then you can see like this 7 can present over here and it will fail. So if you sort it, all these test cases will be passed. So this is one case, and let's see another approach. This is a binary search approach, and let's see two pointer approach. Two pointer is also a pretty straightforward approach. So let's take this example: 2, 3, 3, 4 and 6, and target is 8. Target is 8. So suppose the pointer is here and there is 7, and the two pointer technique, j is here, I and j. So if you calculate 2 plus 7, it is 9. Hmm? And 9 is greater than target. So if we include any of these elements from 2 or 3 or 3 or 4 or 6, anything, this target will be greater than 9. So we can say that 7 is always excluded from the subsequences. So we can decrease this j. Okay. Now j will come here. 6 plus 2, it is 8. 6 plus 2 is 8, and yeah, it's valid. And you can see that, you can include every element in this. Every element in this, and the minimum value would be 2 and the maximum value would be 6. So how many subsequence we can generate over here? 2 power 4 and plus, and now I will be incremented, because now I over here, and 6 plus 3, it is 9. So everything will be excluded, then it will come here. 6 plus 3 is 9, excluded, it will come here. 6 plus 4, everything will be excluded, and it will collide. 6 plus 6, 12, and it will get excluded. So now we can say that only 16 elements are possible. In this way we can do in the sliding window as well. Let's see both the codes. So already I have submitted it. I will show you what exactly I have did. So first I have taken prefix, because we need to compute all this total until 2 power n. We need to compute, and we need to do modulo. And here I have in the left shift. Now I have inserted 1. First I have inserted 1 into the pre-computational array 1. Then 1 is left shifted once. So what it will become? 2. Then 2 get inserted. Now 2 is left shifted once. 100. Now 4 will get inserted left shift. In this way I am storing all the powers of 2 in the pre-computational, and I am sorting it, because in the question it is not mentioned that array is sorted. Then I am iterating, and here I am calculating t minus p of I, and I am taking upper bound, because the target can be equal. Suppose if you take, now suppose we have the elements like this, and suppose our answer is 3, and 3 target is 3, not 3. Now you can say take target as 7. Now 7 minus 2, we are getting 5. So if you take lower bound, this index is 0, this index is 1, this index is 3, is 4. Now if you take lower bound, where it will get inserted? At the point 2. But where we need to insert it? At the point 5, at the index 5. So if you take the upper bound, it will come until the end point. So we need to take the upper bound instead of the lower bound. And we are taking upper bound. And if it is equal, like we can say that suppose we have this and the same test case and the target is 8, not 8, let's take 12. 12 minus 2, not 12 as well, let's take it something, it should be equal, so what we can take, same, 7 we can take. 7 minus 2 and 5, and it's here it is colliding with 5. So if it is colliding with 5, then we can break out of this loop. So we are breaking and we are computing the answer. Now coming to the sliding window part. Now we have calculated the size. Until here all the steps are same. Now I and j, and if the sum is less than t, we are computing the answer and we are incrementing the window size, and we are shrinking, like in the both the cases. If both the values are less than t, we are incrementing I, and if there is less, we are decrementing j. So what would be the time complexity for binary search? We are iterating binary search. We are iterating, so it will take order of n, and for upper bound function it will take log n. So order of n log n. For two pointer technique, it will take order of n. What is the space complexity? It would be constant, because no, not constant. Not constant. We are using pre-computed 2 power, so it will be order of n. Space will be order of n. So thank you guys for watching this.